Kundankar, working as a lecturer in Government Polytechnic Udupi. Today I welcome you all on the lecture series of Mobile and Wireless Communication. That is Unit 8. Let's see what are all the outlines of this session. Introduction to LTE, LTE features, handoff strategies and types of handoff or handover. Before going to a introduction to LTE, let us discuss briefly about the different generations of mobile communication. In the previous topic, you have learned about the different generation. Let's discuss briefly. In the first generation, it's a analog based protocols where only basic voice communication is going on, and it has a speed of 2.4 kbps. After some years, the second generation of mobile is launched in the market where it has a speed of 64 kbps, and it has designed for voice as well as a message, and it has improved coverage and capacity, and it is a first digital standard, that is GSM as well as CDMA. CDMA in the sense code division multiple access. In 2000, the third generation is launched in the market, which is designed for the voice with the same data consideration, that is multimedia, text as well as internet. It is the first mobile broadband, and it has a speed of 2000 kbps. In 2008, the fourth generation is launched where it is designed primarily for data, but all the messages, video, audio, all are based on IP based protocols. It is true mobile broadband, and it has 10,000 kbps. Now we switch on to in a third generation, it is using code division multiplexing, where every message or a voice or a data has to be converted into coded form, and it is very slower during the transmission. So the next generation, this problem is overcome by the next generation, that is 4G LTE, where all the messages, voice and data are in IP form, that is internet protocol form, and it is very easy to transfer a data. You can see how easy it is to transfer a data in 4G LTE. See, this is a architecture of a LTE where the information or data or a voice or a video has to be converted into IP form, that is internet protocol form, and that has to be transmitted into using a mobile communication. The full form for LTE is long-term evaluation, refers to a wireless broadband technology built to support internet access via smartphone and other handheld devices. LTE is registered trademark owned by ETSI, European Telecommunication Standard Institution. The standard is developed by 3G Partnership Project. LTE, sometimes referred as fourth generation, because it offers improvements compared to other standards like GSM, that is 2G, and UMTS, that is 3G, where the LTE technology architecture is based on TCP/IP protocol, that is Transmission Control Internet Protocol, which supports mixed messaging, video, voice, and data traffic. As you see, you can observe in a picture that each message, video, voice, and data can be converted into IP form, which has a downstream of 100 Mbps and upstream of 30 Mbps. LTE is faster than standard 4G. LTE is a successor technology not only of UMTS but also of CDMA 2000. LTE is an ideal technology to support high data rate for services such as voice over IP, streaming multimedia, video conferencing, or even a high-speed cellular modem. This is an architecture. It is a simple diagram of a LTE network. LTE is important because it will bring up to 50 times performance improvement and much better spectral efficiency to cellular networks. LTE is introduced to get higher data rates such as 300 Mbps peak downlink and 75 Mbps peak uplink. In 2000 MHz carrier, the data rate is beyond 300 Mbps, and that can be achieved under very good signal conditions. LTE uses both time division duplex and frequency division duplex mode. In frequency division duplex mode, uplink and downlink transmission used different frequencies, while in time division duplex both uplink and downlink use the same carrier and are separated in time. LTE supports flexible carrier bandwidth from 1.4 MHz up to 20 MHz, as well as both frequency division duplex and time division duplex. LTE is designed with a scalable carrier bandwidth from 1.4 MHz up to 20 MHz. Which bandwidth is used depends on frequency band and the amount of spectrum available with the network operator. All LTE have to support MIMO, that is multiple input and multiple output transmissions, which allow the base station to transmit several data streams over a same carrier simultaneously. LTE uses multi-antenna transmission techniques to enhance the system performance. You can observe a simple diagram regarding a LTE network which has different E nodes. E node P, where all the signals or these E nodes B are called as a towers, from where the signals are transmitted to MME, and again that has to be transferred to PDN. All interfaces between new network node is LTE are now IP based, including backhaul connection to the radio base station. This is a great simplification compared to earlier technologies that were initially based on even T1, ATM and frame relay links, with most of them being narrow band and expensive. The quality of service mechanism have been standardized on all interferences to ensure that the requirement of voice call for constant delay bandwidth and that can be still met when the capacity limits are reached. Works with the GSM, Edge, UMTS systems utilizing the existing 2G and 3G spectrum and new spectrum. Supports handover and roaming to the existing mobile network. The LTE technology is only available in a certain region of the world, including India. Some key features of LTE are as follows. The first feature is LTE provides spectrum flexibility to operate different frequency band and uses bandwidths. LTE provides an single radio access technology and supports frequency division duplex as well as time division duplex. The third feature is channel dependent scheduling allocates the very best resource to the user. The fourth one is the link adaptation technologies and power control mechanisms are employed to allow very high coverage signal quality. The last one is it is at a low cost. It provides much better services. So this is about a LTE. Let's switch on to the next topic, that is handover strategy. In a mobile communication, a whole service area is divided into number of cells called as sectors. These sectors are in hexagonal shape and each sector is having a tower of a same bandwidth or a same frequency. This comes in frequency reuse concept. Since a single cell do not cover a whole service area, cellular system require handoff procedure to transfer calls in progress as the mobile terminal move between two cells. Handoff between the channel in the same cell may also be required for other reason such as load balancing, emergency call handling, and maintaining transmission quality. So now you can observe there are two cells which is of a blue color and a red color. We are calling it as a cell. If a mobile or a transmitter is moving from cell 1 to cell 2, during that process the call has to be there is a region around a blue area, the blue cell and the red cell. If a BTS, that is your mobile is having a movement from base 1 to base 2, then the signals are going also be used in base 1 and base 2. In a cellular network, the process to transfer the ownership of mobile system from base BS to another BS, that is base station, the handoff is not only involves the identifying a new base station but also requires that notice and control the signals be allocated to channel associated with the new base station. Usually, priority of handoff request is higher than call initiation request. When allocating unused channels, handoff must be performed successfully and as infrequently as possible and being inappreciable to the user. So you can see the diagram of handoff procedure when a mobile is traveling from cell A to cell B, where a cell A has a base station A and the cell B has a base station B. When it is in the coverage area of cell A, mobile is in the coverage area of cell A, it receives the signal from the base station A. When it moves from one cell to another cell, the signal strength from base A has to be reduced when it moves towards the cell B. When it crosses the area, it loses the signals from cell A and it catches the strong signals from cell B. This concept is called as the handoff procedure in a cellular system. We can discuss in the next slide. The mobility is the most important feature of a wireless cellular communication system. Usually, continuous service is achieved by supporting handoff or handover from one cell to another cell. The handoff is a process of changing the cell associated with the current connection while a call is in progress. It is often initiated either by crossing a cell boundaries or deterioration in the quality of the signal in the current channel. The handoff is divided into two broad categories. The first one is a hard handoff and the other one is a soft handoff. They are characterized by break before make and make before break. The hard handoff is called as break before make. In a hard handoff, the current resources are released before a new resource are used. In a soft handoff, both existing and new resources are used during the handoff process. Poorly designed handoff schemes tend to generate very heavy signal traffic and thereby a dramatic decrease in the quality of the service. This is the diagram for both hard handoff and a soft handoff. You can observe the difference between hard and a soft. Soft handoff is called as a make before break, and a hard handoff is called as a break before make. You can observe if a person is moving from cell B to cell A, when it crosses the his boundaries, he lost a signal from cell B. Then he catches in cell A. That time, during that time, you can feel that some signal has been lost, or you can't able to hear the sound from the other person. Hard handoff is essentially a break before make connection. Under the control of MSC, the base station handoff the mobile station call to another cell and then drops the call. In a hard handoff, the link to the prior to base station is terminated before or as the user is transferred to the new cell's base station. A mobile station is linked to no more than one base station at any given time. Soft handoff. In a soft handoff, the connection is established with the new radio base station, that is RBS, where the previous one is dropped. In this way, there is no loss of continuity. The mobile station must be capable of tuning two frequencies at the same time. In a hard handoff, the connection will be the previous station has dropped before the new connection is established. If the new one is not established, the call is disconnected abruptly. During the course of all a call, if an mobile station moves from one cellular system to different cellular system, the controller by a different mobile switching center and inter-system handoff becomes like a soft handoff and a hard handoff. So you can observe, you can see a picture about a softer handoff as well as a harder handoff. Handoff request must be given greater priority over a call initiation request when allocating the channels. Handoffs must be performed successfully and as infrequently as possible. A handoff should not cause a cutoff or call drop. A handoff should not be noticeable by the user. The optimum signal must be specified at which the handoff is initiated. The handoff should be performed when there is a drop in signal level due to the moving away from the mobile station from the service base station. The handoff should not be performed when there is a drop in signal level due to fading. To ensure this, the base station monitors the signal level from a certain period of time. The time over which a call may be maintained without handoff, that is called as dwell time. This is a small diagram or a brief diagram regarding handoffs where a mobile is moving from one cell to the another cell. The hard handoff can be further divided into two different types, that is intra and inter-cell handoffs. And the soft handoff can also be divided into two different types, that is multi-soft handoff and softer handoffs. In intra-cell handoff is within a cell. Interference could make a transmission at a certain frequency impossible. The base station controller could then decide to change their carrier frequency. The inter-cell intra-BSC handoff is a typical handoff scenario. The mobile station moves from one cell to another but stay within a control of same base station. You can observe, you can see in the diagram. So this is inter-cell, that is from one base station to another. The BTS is same, the BSC is different, that is intra-cell handoff. Inter-cell handoff. Next we switch on to, you can see a different handoff, that is inter-cell handoff and intra-cell handoff. In mobile calls, in a progress is redirected its present service cell to a new target cell using different channels. Inter-BSC intra-MSC handoff as a BSC only controls a limited number of cells. Handoffs are performed between cells controlled by different BSCs. This handoff then has to be controlled by MSC. The last one is inter-MSC handoff and inter-MSC handoff. A handoff could be required between two cells belonging to two different MSCs. Now both MSCs perform handoff together. You can see this diagram, this system in the last one, that is 1 to 4. In both the MSCs are different. So in today's topic we discussed about the features of LTE and the handover strategies. In features of LTE is long terminal evolution, where all the data and voice and video are converted into IP, and that has to be transmitted through a wireless network which has a faster data rate. And also we discussed about handover or a handoff strategies, which has two types, a hard handoff and a soft handoff. Hard handoff in the sense make before break, and soft is break before make. Now we conclude this session. Have a wonderful day.